Hello everyone, welcome back. So today we are starting a new topic in our series and it will be on trees. Today's lecture will be a very basic and introductory one. So if you are aware of this topic then you can skip if you know all these 3 points that we are going to cover. Else if you are very new then I do recommend to please go through this so that your foundation becomes very strong. So we are going to cover introduction for trees, what are different types of trees, and the application in computer science. First, we will start with our introduction for trees. So I would say that a tree is something as you daily see in your life in park on roads, but you just have to uh, rotate it upside down to visualize as in computer science. So the root of the tree is on the ground, but when we draw a tree in computer science, which we are going to see in few minutes later, its root is generally at the top. So we move from top to bottom. Generally in physical world, in the tree, we move from bottom to top. So in the introduction, let's see what is a definition. So we can say that a tree is a, and you can note this definition down from your exam point of view also, is an abstract data structure that simulates hierarchical structure. Now, this word hierarchical is very important. In the linear data structures that you have studied till now, maybe linked list or arrays, those are associated with word linear, which means every node is at the same level. But here we have a hierarchy. The nodes are having certain levels, certain depth as compared to other ones. You have to visit a node before moving to its child, right? That is, the word hierarchical is very important in this manner. And you can see that it resembles upside down view of a physical tree. And we can also say that wherever we have to maintain the hierarchical relationships, trees are widely used. And this we are going to see when I will present you with its application or usage or examples in computer science, that we will see this point we will see with our examples more. Right? So in introduction only, let me draw a tree, how it resembles. So in a physical world, that's how you define a tree, right? There are many branches. From there are more branches. There are some common ones. They all stem from one thing. That's how maybe a tree might look like, right? But in computer science, what we generally how we generally represent is there is something called a root node. This is like the, you can say, starting point of the tree. Like we have the stem or the main trunk of the tree, of the physical tree. We have a root, and from the root, we can have further nodes. So basically, you can say that all these are nodes. In fact, a root is also node. That's why I've written the word node there. But the root is specifically mentioned because that's the starting point of the tree. All these are nodes. And these lines, the other lines, all these lines, this line here and anywhere else also, these are called branches. So a node, two nodes are connected by a single branch. That is a property of a tree. You can mention here two nodes are always connected by a single branch. That's very important property of a tree. In graph, there can be more than one node. And also one node will have one incoming branch and one outgoing branch at max. This at max word is very important. This is another property. So I am saying there should be one incoming and one outgoing branch. If there is no incoming branch, then that means it is a root node. And if there is no outgoing branch, then it is a leaf node, right? And if there are both branches, then it is an intermediate node. So if I can show you in this tree, let me remove these things, this clutter, so that it becomes more visible and better. So in this tree, let's assume it has something like this also. So now you know what all are nodes and branches. So in this tree, if I have to find what is the root node, so I'm mentioning at the top with blue pen, this is the root node because there is no incoming branch, right? But there are two outgoing branches, so there's a correction that I have to make. One incoming and two outgoing branches. And if you see these nodes, I'm writing L. These are leaf nodes because there are no outgoing branches. You can see there are no outgoing branches here. And these ones are the intermediate nodes because they have both an incoming as well as outgoing branches. Okay, so remember this part. Whenever it is mentioned, it is a leaf node because these terms will be used more common in coming lectures. So please make sure you remember all these. So I hope things are clear till now. And with this, I would say let us move towards the next part, which will be, so introduction we have covered. Let's move to types of trees. Types of trees. So the one that we just saw is the most common one that you might have also have seen. It is called the binary tree. Why? Because there were at max two child of a node. Okay, if you see here, If you assume this is the parent, then this one here is the first child and here is the second child at max. Few nodes are there. For example, this node here, it has only one child. Root also has two child. Okay, so that's why it is called a binary tree. It is said say binary because binary means two, means at max two children of a node. Another one, it is a subpart of this is binary search tree. It is a special part of a special type of a binary tree, which has a property of uh, few nodes are smaller and few nodes are greater. And why we maintain it, I will let you know in next few videos. But it is a part of binary tree only. It also has at max two children for a node. That property still holds, right? But it has a special property that we are going to cover when we will learn more about binary search tree. In this only, another one comes. It is called self-balancing trees. Self-balancing tree means in case a tree is not complete, somehow it is like this. So you can say it is tilted heavily towards one side. Then how to make this into something like so that it becomes um, more balanced, right? So this is one example you can say if you remove this part. So this is a self-balancing tree so that they always remain balanced. And why they are important, we are going to cover that. So next type in binary tree is called heap. Uh, on heap, I have devoted entirely 3 lectures, so I would recommend to go through those if you want to know more. And I will put the link for those in the description below. Next type of tree is Trie, Trie. Uh, do pay attention to the spelling. It is widely used in dictionary. Whenever you have to store how characters are stored in an English dictionary, so at that moment the trie data structure is used. Third part are called segment trees. These are basically used for whenever you want range based operations. Fourth part is something called B tree. These are widely used in databases. They are, you can say, an extension of binary search tree, but they are few more properties as well, how they basically balance each other and how they transfer the weights. So those are B trees. And the last one is called the N array tree. And these are the ones that can have any number of branches. So that is a very, very important point to note as well. And that means the tree that I draw above, it has only two, but this physical tree that I've drawn, you can see that there are many branches. So in the same manner, it is possible that a tree can have as many nodes as present. There is no limitation. There can be many nodes, there can be a single node, anything. It is still be a tree. But what we have to remember is that two nodes are always connected by a single branch. Right? Remember this property. This is the most important property of a tree. And this property that I have written below, this is the important property for the binary tree. This one here, second one. Right? With this, let's move to the third topic that we want to cover today is the application of trees in computer science. application of trees in computer science. I think we have covered this already when we were going through different type of trees. The first is in searching, and I think you know the answer, BST, binary search tree. Second one, sorting, heap, and also BST, because BST is also keeps the data in sorted order. So both are used for sorting. Third, priority queue. There was an entirely different lecture that I took for priority queue. It is implemented using Heap, and I would put the link in description in case you want to go and listen that. For routing or decision making applications, we generally use Trie or segment trees. Dictionary is also another important application done using Trie. And the last one we can say, and it can have many sub applications also, is wherever you need organized, structured data, there you can use trees. Where we can use all this part, example, XML. XML file is entirely based on tree. Then your HTML DOM, document object model, how an HTML file basically renders the elements, in which structure it maintains. It is entirely in tree structure. Or you can say, take the example of files of or directories in your hard drive. You maintain a order in which, so that you can find the things more easily, right? And there can be numeral infinite applications wherever you want an organized structured data. So I think this all I had for the current video. Um, we covered with introduction. Then this is the property that you have to remember for the tree. This important one where I have written. And the second one was for the binary tree. So we covered all these three. In next one, we will be covering more about the binary search tree or the binary tree, and we will see these two types in detail. These two. These two we will see in detail in the next video. So stay tuned. Thanks for watching. If you have any comments, please put down in the comments below and I will be happy to answer those. Till then, see you. Bye.